the directions here say solve each equation by clearing away the fractions. Now, it's telling us specifically to do it using a technique, a stated technique, and that is clearing away the fractions. And what they mean is multiply by some number that would allow all the denominators to cancel away. All right? What that number would be is the least common denominator from throughout the entire fraction, or throughout the entire equation, I should say. All right? So if we look at this, the first thing we would do is find the LCD for the equation. All right? Now, you look at this and you say, okay, well, I'm not worried about the 2, and if you're thinking that, then you're good. But you could also say, well, that 2 could be thought of as a 2 over 1. I mean, it's up to you, but if it's already a whole number, it's irrelevant. So you could go either way with that. All right, the two numbers that we're interested in here are 3 and 6. All right, so on a TI calculator, I'm going to show you how you could find a common denominator. There's a command. Now, in theory, it should be pretty easy, you know, for between 3 and 6 for you to come up with it, you know, from experience from previous years. All right, you've done this enough over the years, all right, at least since 5th grade, 4th grade. All right, I'm just going by memory now because, you know, I think I might have mentioned that I teach a math for elementary school teachers course. So I know what's supposed to happen in those grades. I don't know if it always does. All right, so you should have seen it at least since 4th or 5th grade. All right. That being said, sometimes you just don't want to get bogged down. All right. On the TI, there's a function, math. If you go to NUM, you hit right arrow to NUM, and scroll down, you'll see an option for LCM. So math. So on the TI, oh, that's not a marker. On the TI 84, you'd hit math, NUM, and then it would be option 8. All right. It's a little weird because it says LCM instead of LCD. All right. What this gives is a least common multiple instead of a least common denominator, because what it allows for is the fact that maybe you're looking for a least common multiple, but maybe that multiple is not part of a fraction. So if I were to just say find the least common multiple between these two numbers, then, and those two numbers were not part of a fraction, you wouldn't be technically looking for an LCD, you'd be looking for an LCM. All right. So you pull up that command, it would say LCM. So math, you hit the math key. Then you hit the right arrow to NUM, and then go down to option 8. And then all you have to do is type in the two numbers separated by a comma. All right. So 3 comma 6, 6 comma 3 doesn't matter. I'll do 6 comma 3 because that's the order they gave it. So 6. Now the comma on a TI calculator, it has its own key. You know, people look for a comma because they, you know, as a second key, they think it's like in the background, hidden somewhere. Because, you know, why would a comma have its own key? But it actually does. It's actually pretty frequent that in the TI calculator that you'll use a comma. So 6 comma 3, hit enter, and it'll tell you what the LCM is. All right. And so what that gives you is the multiplier for the equation. It's telling us that if we multiply each term of the equation by 6, it will cancel all the denominators out. Now again, you may be able to do it in your head, and that's great. If you can, then go for it. All right? You're not required to do it this way. This is an option for those of us who may have had a little struggle with this sort of idea in the past. Also, you know, sometimes you look at two numbers, and you're like, okay, 17 and 51. I don't know. And so give it a shot. You know, try it in the calculator, see how it goes. All right. I'll have to refresh my memory on how to do it on the on Desmos, that's going to require a little trial and error. I remember doing it at one point. It could just be as simple as saying LC. Let me look in the functions under miscellaneous. Yeah, it's right there. Okay, function. It sometimes takes a second. All right, but in Desmos, it's a good learning opportunity all around. Anyway, in Desmos, if you need to find a function and you're not sure if it exists, hit that function key and go through the tabs at the top. Now, we're not going to do any trig in this class, at least until the very, very end. We'll do a little bit of trig. So you're not going to be looking too much in the trig menu. Stats we'll do towards the end of the course. So you're not going to be looking there, at least for a while. Same thing with dist or distributions. All right. But miscellaneous, you know, if you're gonna find a weird function in Desmos, it's probably going to come in this menu. So you hit functions and go for the miscellaneous. All right. You see LCM there. Same deal. Type in 6,3 and it'll spit out the value. All right. So again, it's a way for you to get the number without having to think about it, but also it's a way to get an LCM if you have some weird pair of numbers where you're just maybe not familiar, you know, like 17 and 51. I mean, because, you know, you learn the multiplication tables. In the past, you'd learn it up to 12. These days, they're kind of focused on you learning it up to 10. You really should be learning it up to 20, all right? But there's not enough hours in the day for that to happen. So what happens is people kind of fall apart after you get to 12 times 12, at least in terms of multiples. So if I say, you know, what are some multiples of 17? You'll be like, all right, 17. All right, double it, 34. All right, what's the next one? All right, add another 10, add another 7. Okay, 50. Oh, 51. Oh, look at that. It takes a second, you know. But if you have this technology, it'll save you from that. All right. But this one was 6 and 3. So there we go. So we multiply through. 6 times 5 over 6 is just a 5. So 5x plus 12. 6 times 1 over 3 is 2. If you're unsure, put it into a calculator. All right. If you don't know that 6 times 5 over 6 is 5, then type in 6 parentheses 5 over 6 in the TI, or 6 parentheses 5 over 6 in Desmos, and it'll spit it out for you. All right. But you recognize certain little details in terms of cancellations. Order of operations is really important, but there are some aspects that you can kind of rely upon, all right, in terms of just number relationships. 6 divided by 6, for example, is equal to 1. So they would cancel, leaving you with just a 5. 6 divided by 3 is equal to 2, times the 1 would give you the 2. All right, so that could be an avenue for you to get your results.
Should we do the do now? Like, do we need to do the do
No,
now?
not unless we're doing it together.
Oh.
Yeah. So next step, I would subtract off the 12. And you'll notice none of these instructions say to justify with a property of equality, so I'm not doing any of that. So 5x is equal to negative 10. Divide by the 5. And we get x is equal to negative 2. All right. Going back to what we talked about yesterday, if a question just asks you to find a solution, it's pretty simple on Desmos. You take the left-hand side. If I can draw a line. So we have 5x plus 2 equals 1/3. Oh, I'm sorry, 6x plus 2. All right. The left side goes in as one equation. We would say y equals this. The right-hand side goes in as another equation. We'd say y equals that. See where they cross. All right, so y equals 5 over 6 x plus 2. Y equals 1/3. Bring it in so you can see the zoom. Doesn't have to be pretty. Tap on the intersection once to show the gray dot. Tap on it the second time. We're just pulling out the x value. All right. That y value, that's a 1/3. That's great, but we already knew that. It says it right here. Y is 1/3, so that's not a surprise. It's the x value that we care about. We solve for that algebraically. We now have it graphically.
When we take the regions, will we have to sort of work in graph form?
Not necessarily, because you're going to have it, unless they changed it, and there's no reason why they would, 30 multiple choice questions. So those you don't have to show any work. Now, if you choose, when you get to the free response questions, if you choose to do it graphically, then what you would do is just draw a quick sketch of your graph and show how you got the solution.
But is it, I guess my question is, because I don't know, I personally find it easier to either write it out or like not do it on the graph, so that
Right. In some cases, you'll have to do it on a graph because the directions will say so. Some cases, you'll have to do it algebraically because the directions will say so. And in other cases, you'll have a choice. So you just got to be able to go in each different direction. Now, on the TI, all right, I said yesterday that I'd show you how to do it on the TI. What you would do is very similar, all right? So the first step here of identifying the equation, the original one as two separate equations, you're going to do that same thing, except you're going to type in your equations into the y equals menu. So you go into y equals. Now I got all this other nonsense from another class in here, so let me turn off my stuff. So nothing to see here, nothing to see here. Pretend. Okay. So you start off with the 5/6x plus 2. So on the TI, there's two ways to put in a fraction. So on the TI, so this is Desmos. On the TI, you're going to do y1 is equal to 5/6 x plus 2, but it's a question of how you get the 5/6. So there's two ways to get that. You could type it in as parentheses 5 divided by 6, or you could hit alpha y equals option 1. All right. So if I hit alpha y equals option 1 says n over d, stands for numerator over denominator. It'll bring up a fraction. All right. It's a pretty useful feature. It's actually so useful that you start questioning why that's hidden away, why there's a key for a comma, like a dedicated key for a comma, but you got to go hunting around for a fraction. You know, it's annoying, but it is what it is. All right, so then you type in your 5, hit the down arrow because it's not a touchscreen, so that's annoying. Type in the 6, hit the right arrow. Now you type in the x. All right, so to get an x, you see this key here that has all this funny business on it, x with a t, with a theta. It's called a theta, by the way, Greek letter. And an n, all right? Depending on the mode you're in, it'll bring up one of those different characters, all right? Your default mode is function mode, so when you hit this key, an x will appear. All right, so long story short, you hit this key when you want to bring up an x, until further notice. All right? Then you add a 2. So plus 2, that should be fine. Then hit enter. All right, enter to lock it in. All right, so that's pretty typical. You know, most of the time, if you're going to lock something in, you hit enter. All right, then I want to get a 1/3. So if I put in the 1/3, so that'll go in y2. Again, I could do that with alpha y equals to make it look nice, or I could just type in 1 divided by 3. Alpha y equals option 1, 1, down, 3, over, enter to lock it in. All right, so now you have your two equations in. We want to see where they intersect, just like we would on Desmos. All right, so we're going to hit, so to show the graph, hit zoom, followed by the number 6. We don't hit graph typically because graph will just bring us to the window that was used for the previous problem. If we hit zoom and then option 6, which says standard, that'll bring us to a nice negative 10 to 10 window, all right, for X and Y. So I'm going to hit zoom 6. It's definitely not as good looking as the Desmos graph, unless you got the nice color screen, you know, it's the distinguishing graph and all that good stuff. So that's fine. But we do know that there's a horizontal line here, y equals 1/3, and a diagonal line, and they cross. This is the part that people typically will not enjoy doing, at least initially, because it's a couple of extra steps. But it'll get the job done. Once you become comfortable with it, it becomes second nature. So you're going to hit second trace, 5, and then hit enter 3 times. So enter, enter, enter. All right, this gives us the intersection. All right, so second trace is right next to graph. Option 5 says intersect. And then you just hit enter 3 times. Later on in the course, I'll explain to you why you hit enter 3 times. Right now, there's no context, so it won't be meaningful. Enter, enter, enter. And then it'll give you that X value, which is what we care about, of -2. Which is what that algebraic solution was. Now, again, I got to say what I said yesterday. For a simple equation, you're probably not doing it this way. You're probably not doing it on a TI. You're probably not doing it on Desmos for a simple equation. But when you get to the more complicated stuff down the line, you want to keep an open mind to this approach. And I promise you, there will be some of you that are going to dismiss this technique right now and say, forget it, I'm not doing that. That's dumb. That's way more difficult. I might even be the same person. But you might also find yourself in 5 months coming up to me being like, you know that technique for like finding the intersection? How do you do that again? I forgot. And then I'll be like, yeah, you forgot. I know exactly who you are. You didn't like it then, but you like it now because you saw how complicated the equations got and you don't want to do the algebra anymore. I know all about you. You know, so, and that's good. That's the growth that I'm looking for. All right. So when it comes to something like number 4, you can look at it and say, all right, I'm going to do it algebraically, I'm going to do it on a calculator, and then you have the option now. All right. Unless the question says you have to do it one way or the other, in which case you're stuck. All right. So right now, at least, you want to be familiar with the LCM function, just because if you get stuck with 2 numbers that you can't find a common denominator for or common multiple for, you're going to be stuck on the problem completely. In this case, the LCM would be a 12, but if you didn't know that, you'd go to function, LCM, pop in the 3, pop in the 4, and it'll spit it out for you. All right, same thing using the appropriate technique on the TI, math, NUM, option 8. All right, so, I typed it onto Desmos, but then I didn't show you. So LCM option, LCM is in function miscellaneous. All right, but math, NUM, option 8. Oh, that's another aspect of the TI that's kind of annoying. Sometimes it puts the command in a place where you don't want it. So quit, second mode to quit. Math, NUM, option 8, 3, 4, lock it in. All right, lock it in by hitting enter. All right, you start getting used to the way I say things, and you start understanding what I mean when I say things like lock it in. That means hitting enter. It's just a way of speaking that doesn't always land. All right, so 3 goes into 12 4 times. 4 goes into 12 3 times, 3 goes into 12 4 times. And you'll see that I only took into account one of the 3s because the other one was just a repeat. It didn't matter. It didn't factor into the whole thing. All right. So 8x minus 3 is equal to 4. Add the 3. Divide by the 8. For this question, you might want to do it using technology because you got a 7/8. You're like, oh, I probably screwed that up. But I would caution you, or at least remind you, that if a question starts off in fraction form, you shouldn't be shocked if you get an answer in fraction form. Right? I mean, that seems logical. All right, so you could check this on your calculator, just make sure things went the right way. One last thing. I know there's only like 10 minutes left. I wanted to give you some time to work on your calendars. But if you have 3 different numbers in your denominator and you need to find an LCM, so I'll just throw a quick example here. Let's say you have 3, 5, and 2, and you need to find the LCM. There is no mechanism to do an LCM 3 terms at a time. So what you'd have to do is find the LCM between 3 and 5. All right, so I'll do that. That'll give you 15. So now we have these two accounted for. Then find the LCM between that result and the remaining value. So you do it 2 at a time is what I'm saying. All right, and so this would be your LCM for those 3 values using the technology. All right, you could play it out numerically and ask yourself, what is the smallest number that I could divide by 3, 5, and 2 and figure it out? But if you don't have it, like you can't figure it out, or maybe you're just not with it that day, at least you have something to fall back on. All right. Okay, so that's that.